Hello again, viewers. We welcome you back to Quest, which is an inter-school science quiz brought to you by Education and Kendriya Vidyalaya and the National Council of Science Museums. I'm your host today. My name is Gaurav Gupta, and before I go any further, I am going to request the Director of National Council Science Museum Headquarters, Dr. Jayantos Thanapathy. Give him a big hand as he comes in. Hello, Dr. Thanapathy.
Yes.
Are you rested after 1 week of from our last episode?
Yes.
Yes, you are. You have some fresh new experiments for us today?
Many interesting exhibits.
You do?
Yes.
Okay. Let me begin with first introducing the teams to you. On my right is the J.C. Bose team, and they are the girls from GD Birla Centre for Education. And you are?
I'm Moushumi Das from GD Birla Centre for Education.
Hi, I'm Shucharita Sen.
Hello, I'm Anandita Datta.
Have you been watching our quiz show on television before?
Yeah, a few episodes.
You find the questions easy?
Not really.
Not too easy. Okay, let's see what you do with your set of questions today. And on my left are the C.V. Raman team, and they are the boys from Kendriya Vidyalaya, Salt Lake. And you are?
Hi, I'm Shayantan.
I'm Arnav. And I am Vivek.
And have you also been watching our show?
No.
Not been watching our show. Well, you know, now's the time to tune in and watch our show regularly every week. I'd also like to tell everybody that Quest is a quiz with the main purpose of educating people rather than giving that competitive edge. But having said that, I will still say, let the best team win. The format of today's quiz is very much the same as in the past weeks. We have a total of 7 questions. The first 4 are direct questions. 20 points for getting your correct answers on the direct questions and 10 points for getting them on the passes. The last 3 questions are on the buzzer. Now teams, remember one thing. If you hit that buzzer, irrespective of whether the question has been asked or not, you've got to be ready with an answer. It's plus 20 if you get it right and minus 10 if you do not. Well, let's not waste any further time on any further preliminaries and get on with today's set of questions. Dr. Thanapathy. So I hope both teams are set for a very interesting round of Quest. The first question goes to the team seated on my right, that's the J.C. Bose team, the girls from GD Birla Centre for Education. Dr. Thanapathy.
In this exhibit, I have a curved surface here. And there are parallel channels. Okay? At the focus of this curvature, I have placed a steel ball, which is fixed. I am going to release with some velocity another steel ball from any of the channels. It hits the other ball. Let me try it through another channel. It hits. It will always hit, so long these are released from these parallel channels. Why this happens?
Reflection of light. Parallel rays of light always pass through the focus. Like it's according to the.
You have to speak a little louder, please.
According to the rectilinear propagation of light, parallel rays of light when they hit against a concave mirror, they'll always pass through the focus. There's something like that in mechanics. It's just the same thing in mechanics.
What is this curvature?
It's a concave.
Concave? What is the shape? Concave can be anything.
Could you be more clear on what exactly we are asked to answer? Like
I'm asking you why the ball, when released from the parallel channel, hits the other ball which is kept at the focus of the curved surface.
Because any ray of light that is parallel to the principal axis, when it hits a concave surface, it reflects back through the focus of the mirror.
I see.
it's something like the same
Do
thing in
you
mechanics.
have any better answer with you?
The same as
Other than that, what they have said? No? Okay, I give you full marks for this. This curvature is a parabola. Okay? And when a ball is released from this point, it gets reflected from a particular point. And yes, it follows the laws of reflection as it is followed in case of light. So the angle of incidence is equal to the angle of reflection. That is true in case of this mechanical exhibit 2. So your answer is correct.
Thank you, sir.
Good answer there then, Shucharita. You pick up 20 points for your team, and you've also now learned how to improve your game of carom. Audience, let's have a big round of applause for the team. And now with the score reading 20 points to the JC Bose team, the second question is for the CV Raman team.
In this exhibit, we have 5 steel balls, okay? And they are of equal mass. All are identical. If I release one ball from one end, you find one ball is moving out from the other direction. Right? Let me release 2 balls together. Then 2 balls are deflected. My question is, if I release 3 balls, what will happen? And why that will happen?
Next 3 दिखते 3 together. Sir, when we release those 3 balls,
Okay.
then the 2 balls which were at rest, they will start moving, and when they hit back, the other 2 will again move. And
You mean to say, if I release 3 balls, these 2 will move,
yeah,
okay? And they will hit the remaining 3 balls. And from the other end, 2 balls will be deflected. Am I correct?
Arnav, you must hurry up because we have a time limit.
I would like to make some amends on my question.
Okay.
When all the 3 balls are released, then 2 of them will again go, then 2 will come to rest immediately, and the other 3 again will go up.
You mean to say, if I release these 3 balls, these 2 will go, and 2 of these will be at rest.
Again, and the third one will also go with
So
them.
this one will also go.
Yeah.
Okay, let us see what happens.
Sir, does it pass to us?
No?
It's not passed as yet.
No? Right? I'm releasing 3 balls. Let us see what happens. You're absolutely right. Now, you have to tell me the reason for this.
So the balls should have the equal mass.
They have equal mass.
So
Sir, it follows the conservation of linear momentum.
Conservation of momentum, it follows, yes. What else?
The 3 masses should be equal to the next 3 also.
Right.
So when the 3 balls are moved, the other 3 also move, so that the mass should be equal.
Okay, absolutely right. So you get full marks for this. But one more point is there. Suppose I release 2 balls from here. Why one ball is not moving with double velocity?
So
If you consider conservation of momentum, you see momentum is mass into velocity. So if I release 2 balls, instead of 2 balls being deflected, why one ball is not moving away with double velocity? Okay, there are 2 things which can be proved in this exhibit. I can tell you that. One is conservation of linear momentum, mass into V. Secondly, it also shows conservation of energy. In case of linear momentum, mv is equal to mv, and in case of conservation of energy, half mv square is equal to half mv square. So if you solve these two equations, you will get n1 is equal to n2 and v1 is equal to v2. That means n1, if that is the number of balls, if you release one ball, n is 1, then one ball will be deflected. If you release two balls will be deflected. Similarly, when you release three balls have to go from the other end. So that's the full answer for this question.
But you haven't told us, Dr. Sanapati, what happens when you release all 5 together?
Oh, they will just oscillate.
They just oscillate. Well, we are sure that the C.V. Raman team is not oscillating with their answer, because they've answered absolutely correctly. Well done. Let's have a big round of applause for them. So 20 points apiece as we go in to the third question of today's quiz. For the next question, we'll need a volunteer. Do we have any volunteers in the audience? Plenty of volunteers. Why don't you come up? Hold the mic. What's your name?
I'm Shomu Moitro from Pathabhavan.
Parabolic. Ready to be experimented upon?
Oh, yes, sir.
You are. I hope you do know what Dr. Sanapati has in mind.
Not actually, sir.
You don't. Good. I'm going to move out of the way and hand you over to him. Come, Somu.
This is the question for J.C. Bose's team. This ball is a heavy ball, and this is suspended from the ceiling. Okay? I'll bring it near my nose and will release it and will stand here. Of course, I'm not going to do it. I'll experiment with him. Okay? You have to tell me whether this is going to hurt him or not.
No, sir.
Okay.
Okay.
Let us experiment first.
Okay.
You can almost feel the tension today, Dr. Sanapati. Shoma, I hope you're not worried any longer.
Okay. Now your answer.
So this is because of damping effect.
This is because of damping effect.
That's why the oscillation is like, the energy is not conserved. It is some of it is dissipated. That is why if the total energy was conserved, then it would have hit him rightly.
Yeah.
But then since there's atmosphere, there's friction. So
Very
there's
good.
damping.
Very good. That's the correct answer.
Thank you, sir.
See, this is working like a pendulum. Okay? Now, because of damping, the amplitude will gradually reduce. So, from the point where I am releasing it, it cannot go back to that point because of damping. So, it will be slightly less than the previous distance, and it cannot hurt him.
Okay, you can go back to your place. Let's have a big round of applause for the J.C. Bose team. Tell me, Dr. Sanapati, before we go into the next question, any more spherical objects for us?
Oh no, that's the end.
Are we done with them finally?
Yes.
Okay. So 40 points to the J.C. Bose team and 20 to the C.V. Raman team.
I'm boiling plain water in a round bottom flask. The flask is kept above a heater. Watch carefully. Not the boiling, but the experiment.
Dr. Sanapati, am I in any danger? Do I need to move
Oh, no,
back?
no. Absolutely not.
No danger whatsoever. You're not making tea for us, are you?
No.
No, all right.
Removing the flask from the heater and closing the mouth of the flask by a cork. See, the boiling stops. It will stop after some time because there is no more heat supplied to the flask. Now let me pour some cold water in it. So the boiling increases. Doesn't it? Whenever I pour cold water on the flask, the water inside starts boiling. So it is a case of boiling by cooling. Now the question, what is the principle behind this boiling by cooling?
We think this is due to the pressure,
Okay.
which is due to that cold water which is poured outside. The I mean to say that inside the pressure is less.
Inside pressure is less.
While
No?
can't we discuss a little more?
Oh, the time is up, I believe.
I believe
So it is passed on to the next team.
Sir, when the cold water is poured,
Yeah.
the pressure inside, the air pressure inside, it's lowered and the air contracts. So there is a little space
Partial
left,
vacuum,
a partial vacuum is created. So the dissolved air that was in the water, that comes out in the form of bubbles.
Oh, no, that's not the correct answer.
Good try, Moushami. Bad luck. Any takers in the audience? Yes, I saw you first. Why don't you come up in the back? Yes. Please come here. What's your name?
I'm Devadip from South Point High School.
Hold the mic. Face the camera. Let's have an explanation from you.
Okay, this is due to the decrease of superincumbent pressure. When we pour cold water on the flask, the air contracts, so the pressure decreases. Now we know that the boiling point of water depends on the superincumbent pressure, and as the pressure decreases, the boiling point also decreases. So it is lowered much below 100 degrees centigrade. So that is at the room temperature only, water begins boiling when the pressure above the water surface is decreased. That is why it happens.
Very good. Absolutely correct answer. Absolutely correct answer.
Well done. Here's a small memento for you from Quest. Great answer. Let's have another round of applause for him. Dr. Sanapati, can you add to that, please?
Yes. Now I'm giving you the answer in a very simple manner. You know, initially the flask was kept on the heater, it was boiling, and the mouth was open. So it was boiling under the atmospheric pressure, the air pressure in this room, and it was boiling at 100 degrees centigrades. Immediately after removing it from the heater, I closed its mouth. Now while boiling, some air which was inside the flask that came out. Since I closed the mouth, the air pressure inside was less than the normal air pressure. And what our friend has said is absolutely right, that is, the temperature at which a liquid boils depends on the pressure. In the next case, the pressure was lower already, so the water can boil only at a lower temperature and not at 100 degrees centigrades. So when I was pouring cold water on it, I was really cooling down the liquid below 100 degree, and at that temperature it started boiling. So it is a case of boiling under reduced pressure.
A very good explanation there, Dr. Sanapati. C.V. Raman team, I'm afraid you do not pick up any points there, but then neither do your opposite team, which is the J.C. Bose team. Scores remain exactly where they were, 40 points to J.C. Bose and 20 to C.V. Raman. Welcome back to Quest. We are now into the final lap of today's quiz. Yes, that's right, it's the buzzer round. I'm going to go over the rules of the buzzer round very quickly for you once again. Whichever team hits the buzzer must have the answer ready with them, irrespective of the fact whether the question's been asked or not. We may even ask them to frame that question and give the answer too. So teams, please be judicious before hitting that very alluring switch in front of you. All right. 40 points to JC Bose, 20 to the CV Raman team, and the next question is on the buzzer.
Here is a naughty boy who likes to play cricket throughout the day and hates maths. So if I show him a maths book, he turns his face. And if I show him the cricket bat and ball, he is so delighted, he looks at it. Tell me what is the reason?
Yeah, inside there are two magnets.
Okay.
When
Opposite poles always
attract each other,
Yes.
so it has been arranged in such a way that the boy's face and that bat or
And
his
ball?
Bat and ball, they are oppositely charged.
They are opposite poles.
Yeah, opposite poles. I'm so
if
sorry.
the book is
Shown to
Turned,
him.
it repels
it will repel it and it will move.
towards the bat.
Yes, that's the correct answer. So I'll show you the arrangement here. Yes, we have two magnets arranged in such a fashion that when they attract each other, that means when they are opposite poles, and the paintings are arranged in such a way that the boy only looks at the cricket bat and ball. That's the correct answer.
Well, any of you naughty boys here? Not naughty boys?
Yes, sir.
Yeah.
Fond of maths?
No.
Not fond of maths? Very fond of cricket?
Yeah.
Okay, 40 points apiece, and we move on to the second question in the buzzer round. With the scores reading deuce, let's see which team gets the advantage in the next question.
In this white rectangular board, I have written something with some invisible material. Okay? I'm going to spray ammonium hydroxide on it. Ammonium hydroxide. Tell me with what chemicals I had written the invisible word, and after spraying ammonium hydroxide, what is the reaction?
Come on, both teams, one of you must go for the buzzer.
Okay, we'll go to the audience.
No team going for the buzzer, right? I think you were very keen to answer. Why don't you come up? Come here. Hold the mic, face the camera. What's your name?
Ushrati Das from Birla Centre for Education.
And do you have a plausible answer?
Yeah.
Yes, why don't you tell us?
It is phenolphthalein.
This is phenolphthalein.
Yeah, it's
Okay,
turning
that's correct. Now when I am spraying ammonium hydroxide, why the color changes?
Because ammonium hydroxide is basic,
Okay.
and phenolphthalein is a basic indicator, so it turns
Right.
it from colorless to pink.
Yes, absolutely correct. Very good.
Let's have a big round of applause for Ushati. Well done. Ushati, we have a small memento for you. Well done. You can go back. Thank you. Tell me, Dr. Sanapati,
Yes.
you were able to make something appear.
Yeah.
Can you also make it disappear somehow?
Yes.
You
If
can?
I hold it for some more time, you know, the ammonia from the ammonium hydroxide will evaporate.
It will evaporate.
And this quest written in red will also disappear. It will become white once again.
Right, scores are still exactly where they were, 40 points to each team. Viewers, we hope you don't evaporate, just stay exactly where you are. We're going to come back with the final question, and it's come right down to the wire. Let's see which team takes home that advantage. Welcome back. This is positively the last question of today's edition of Quest. And as you're aware, it's on the buzzer. Scores are exactly where they were, 40 points apiece. Dr. Sanapati.
I have a coil of wire here, a big coil, and I'll pass alternating current from the mains into this. Here is another coil, but this is not connected to mains, or it's not connected to any cell. I'm placing the smaller coil on the big coil. The lamp glows.
You can't see, sir.
It's glowing.
Can you see?
Yes, sir.
It's glowing. If I remove the coil, it goes off. If I bring it back, it glows again. Why this is happening?
Okay. J.C. Bose team?
Sir, is it because of Faraday's effect, Faraday's law? Like when electricity is flowing, since an AC current, it's alternating the sides. Once it's flowing clockwise, then it's flowing anti-clockwise, whatever the coil may be. Okay. So when the when we know for like normal electromagnets, if we bring the magnet close, electromagnet close
You
to
mean to say electromagnetic induction?
induction. Yeah.
Okay. In this case, there is no magnet.
So there's no magnet, but this current is flowing, so it is this.
That is producing magnetic field.
Yes, sir.
And that is inducing current in the secondary one.
Yes, sir.
What you want to say?
Yes, sir.
Okay, that's right.
Let's have a big round of applause for them. Very good.
You know, this system is working like a transformer. Here you have the primary coil, and here you have the secondary coil. If you pour some iron rods inside, the field will be more and the glow will be more. So to make it simpler, I have not put any iron core inside. Okay, that's the right answer, which you have given.
Now the final scores. The J.C. Bose team, that's the girls from G.D. Birla Centre for Education, Kolkata, they have picked up another 20 points in the buzzer round. Their final score reads 60 points. And the boys from Kendriya Vidyalaya, Salt Lake, that's the C.V. Raman team, they remain on 40 points. We thank both teams for joining us in our show today. Well done, girls. Let's have another big round of applause for them. Here's a small memento from Quest. Thank you. Boys from Kendriya Vidyalaya, better luck next time. Thanks for coming, and well done. If you have liked our show, do write in to us along with your comments, or in case if you're a student and your school wishes to take part or send a team. Our address is Quest, care of Doordarshan Kendra, Kolkata, 18/3 Uday Shankar Sarani, Golf Green, Kolkata 95. We'll see you again next week at the very same time. Do remember to join us then. Till then, it's goodbye.